Hi Copper Canyon Algebra 2, it's Miss Castro again. I hope you guys enjoyed your 4-day weekend and you're ready to get back to work. So today you should be starting 9.4, which is evaluating 6 trig functions. So it sounds a little different because we've only talked about 3 trig functions, sine, cosine, and tangent. So today we're going to introduce 3 more trig functions. Also, we're going to go from that unit circle model. So if you guys remember the unit circle, remember the unit circle is called the unit circle because everything here is radius of 1. So today we're going to be talking about some circles as well. All circles are proportional. You have small ones and you have bigger ones. They all have similar properties. So now we're going to be talking about circles but on a larger scale. They're no longer radius 1, and so because they're no longer radius 1, you have to do a little bit more calculating for that reason. One thing I want to remind you about though, because you're going to need this, if you have triangles that are not radius 1, you're going to have to be using this quite a bit. The Pythagorean Theorem. So on this paper here, I've got some Pythagorean Theorem shortcuts. Now notice I did not put a squared plus b squared equals c squared. I used variables that we're going to be using in our lesson today, so it can have that transfer, okay? We're going to be using x, y's, and r's. X and y are the points, and r is the radius, right? Now the reason we're doing that is because radius is no longer 1, it's going to be something else. It's going to be on a larger scale. You're going to have larger circles, larger triangles. So here's a quick shortcut. I just want to remind you guys about Pythagorean Theorem and the 2 scenarios you can run into. You can have a right triangle that is missing the hypotenuse. That's the long side. So if you have a right triangle that is missing this long side that's across from the right angle, you're going to have to do adding. So take a look here. I took the 2 legs, 4 and 3. Remember, the formula says to square the 2 things, and in this case, I'm adding them. 3 squared plus 4 squared equals 25. Don't forget, this is a common step students tend to forget. They square them and add them, but then they forget that they can't just leave it 25. You then have to take the square root of that number. And so actually the missing side here, the hypotenuse side, is 5, according to this triangle here. On the flip side, take a look at this right triangle over here. You know, some of you might think, oh, this is the same exact thing, but take a look. You actually have the hypotenuse side this time. So you're not going to do the exact same thing because you're given different pieces. So when you have the hypotenuse side, you have to remind yourself that you actually have to do subtraction on this type of Pythagorean theorem. Okay, so again, take your 2 sides. Your 2 sides that you have, obviously start with the bigger one. So your bigger side's 13. So you're going to take 13 squared, but you're going to subtract it from the other side, 12 squared, and this is actually going to give you 25. Then again, don't forget, you can't just leave it 25. You have to take the square root, and now you get 5. So this missing side here, this leg, is actually 5. These are 2 different scenarios of Pythagorean Theorem, and I just want to remind you because you're going to be doing quite a bit of Pythagorean Theorem work within your problems. Okay, so let's go ahead and take a look at example 1 here. All right, so in this example, I want you to find all 6 trig functions. So some things to remember. I went ahead and color-coded them here. So you have 6 trig functions. Here's the original ones, cosine, sine, and tangent. But the new ones here are right here. You have something called cosecant, or you have something called secant, cosecant, and then cotangent. Now here's the thing I really want you to pay attention to. So in the past, when we were doing the unit circle, everything was over 1, so it didn't sound too strange. So now you're getting used to things that are not 1. So the formula for cosine, remember cosine still is x. So this is x over the radius. Cosine is still x, but now you have to divide it by whatever the radius is on your circle or on your triangle that you're looking at, okay? Same thing here, sine is still y, so the formula has sine y, but again, it's getting divided by the radius. Now, tangent hasn't changed. We didn't talk a lot about tangent on the last video, but tangent still has a formula. It is y over x. Okay? Now, here's the important part. Notice I color-coded. I color-coded cosine with secant because take a look at the 2 ratios for each one. Cosine was x over r, and secant is r over x. It is actually the reciprocal. Now, what a lot of students tend to trip up on is how to remember them. I have a tricky, just kind of a cheesy way of doing it. If it starts with C, then its inverse starts with the S. They're different, okay? If it starts with C, this one starts with S. Look at sine. It starts with S, so its reciprocal starts with the other letter, C. So, you know, it's not like, oh, if it starts with C, it starts with C. No, it's switched. If this one starts with C, then the reciprocal starts with S. If this one starts with S for sine, then the reciprocal starts with C, cosecant, okay? And then tangent's not that hard. You can see that it has an inverse function here. It's cotangent. I just say think about the t. This has a t in it, this has a t in it. You can't really mix those two up. All right, so let's go ahead and take a look. Our goal today is to find all 6 of these given just this diagram, okay? So first things first, you need to see your triangle. I told you we're going to be using a lot of Pythagorean Theorem here, and so the first thing you want to do is figure out, hey, where's my triangle, where's it at, and how am I going to find all those sides, okay? So here we go. First things first, they give you this point on a circle, right? Now, what you have to do is create your own triangle. So I'm going to go ahead and take this diagram and just kind of draw myself a right triangle right here. Now I'm keeping to that point, but do you see this right triangle I was able to create from this point that's here? So this is actually what I'm going to be using my information on, okay? So I'm going to go ahead and redraw that. That is way too small. I'm going to redraw it over here off to the side. Doesn't have to be pretty. It's just a model that we're going off of. So I took this triangle that was right here and just kind of plastered it over here, okay? Now, the next thing you want to do is get our sides straight. So remember, on your points, you have x, then you have y. Now, the other thing I think is very important for you to keep in mind, x goes left to right. So when you're thinking about the x-axis is left to right. Your y-axis goes up and down. That's important because when you come to label your legs, you want to make sure that you're labeling your legs accordingly, okay? So my x goes side to side, so when I come over here to label the 15, this is negative 15, that's this side right here, because it's the one that's going left to right, okay? So that's that side. The y value is going up and down, so that would be this leg right here. This is the one that's going up and down. So the y value here was negative 20. Okay, now here's the thing. Technically, when you're doing a triangle, you can't have negative side lengths. So even though these are negative in my mind, I'm not going to be using those negatives in my Pythagorean theorem, but I will be using them in my final answers here. So I'm going to leave them there so we just don't lose track. So let's talk about Pythagorean theorem real quick. So I want to plug these values in, right? So remember, we're doing x squared plus y squared equals r squared. And so now I need to calculate my r. I don't have this right now. Okay, so thinking back to that little paper I showed you, are we going to be adding the squares or subtracting the squares? So I'm missing the long side, so since I'm missing the long side, I'm going to be adding the squares. So I'm taking negative 15 squared, negative 20 squared, and I'm going to find out what r squared is. Okay, definitely have a piece of paper and calculator ready with you because I wouldn't want to figure out what that is. Notice I put the parentheses there because if you're using Desmos, you should be using parentheses. You will get the wrong answer if you do not use parentheses on that problem. All right, so I'm getting 169. I just typed all of this side into the calculator, boom, 169 is what I got. But remember that right now, 169 should not be where you stop. You should be thinking, whoa, that's huge. It is huge. Don't forget that last step. You now have to square your final answer here. So we're going to square this answer. Square root, not square it. So square root, square and a square root cancel out. Again, calculator time, if you don't know this one, square root of 169 is 13. So our R value here is 13, okay? So that's that missing side length that's up here. So let me cross this question mark out and let me go ahead and put 13 right there. You have everything you need now to answer all 6 of these trig functions here. Okay, so let's go ahead and start off with the first thing. The first thing I recommend you do is start with the original ones. Start with cosine, sine, and tangent. Because once you have these 3, the other 3 here that are new are real easy to fish out. All right, so here we go. Let's start with cosine. So cosine theta, all right, is supposed to be x over r. So let's come back over here. I guess I should have labeled these. Remember, x goes side to side, so maybe I should have put a label there, x. And same thing here, I should have labeled this y, so we don't get confused. Like, what's x and y? That's x, that's y, that's r. I have all my information ready to go. All right, so cosine theta is x over r, so that's negative 15 over 13. Okay, there's one trig function. The next one is sine, so let's do sine now. So sine theta, same thing. Your formula for sine is y over r. So your y value is here, the negative 20. So you're going to do negative 20 over 13. And there's your sine function there. And then the next trig function we have there is tangent. So tangent theta, that's y over x. So your y is negative 20, your x is negative 15. Negative 20 over negative 15 is that. I'm going to stop here just for a second because even though I plugged those numbers in correctly, I want you to stop and think. You cannot have double negative for here. When you have a negative divided by a negative, it automatically turns into positive. So I'm actually going to erase these, and I'm actually going to write a plus sign there. So when I see it later, I'm like, oh yeah, it changed to positive. So I clearly put a plus sign there to remind me that, oh, it changed to positive. Double negative makes a positive when you divide. All right, so there's the three original trig functions. Now we're going to go over to the other ones, the new ones, and I'm going to show you how easy it is now that you have these answers. So put an arrow here. So remember, cosine is related to secant. So to find secant theta, all we got to do is take what's here and flip it. So now instead of saying negative 15 over 13, it's going to say negative 13 over 15. And that's it. That's how simple it is. So once you have these three just kind of come out. You don't even have to really do anything for them. You just got to remember the reciprocals. All right, and then the last one here, cosecant theta. Somebody's at my door. I'll get it in a minute. We got negative 20 over 13, so this is going to be negative 13 over 20. All right, and then the very last one here, tangent, cotangent will be cotangent. And so again, it's still positive, but now it's going to be positive 15 over 20. And there you go. There's all 6 trig functions. Looks like a lot of work, but really simple. A lot of writing. Make sure you have a calculator nearby. Make sure you have pencil, paper, all that stuff. It's really not that bad. Good luck to you guys.